Hello class. Today we will go over the homework for the long division as well as the test. Now I meant to make the test review video where I go over the answers as of yesterday, but because some of the students were not able to turn in the tests due to games and things like that, I postponed it to today. So today what we're gonna do is you guys are just gonna watch the video and make sure that your answers are fine, and make sure that you're really just getting to the bottom of this. After you watch this video, if there's any questions about how you approach the answer for these guys, just please let me know. Next week, we will go more in detail about long and synthetic divisions. Today, we are just going to look at the answers for these guys. There's no assignment for you guys to finish up. We just finished up the test this week, so I want to give you guys a break over the weekend. And next week, we'll start fresh on a new topic before the Thanksgiving. Alright, so for these guys, the long division, for the first question, we should write x cubed plus 4x squared minus 6x minus 12, and divisor is x minus 2. So you ask yourself again and again, how many times can x fit in x cubed? So that would be x squared. So now we'll write x cubed minus 2x squared, because if you multiply negative 2 with x squared, that's what you get. And then remember, you're going to subtract these guys, and that will distribute the signs to both x cubed and the negative 2x squared, which will make this into a positive. So that would make this 6x squared, and these two would cancel each other out. Then you bring this down, and then you ask yourself again, how many times can x fit into 6x squared? Well, that's plus 6x times 6x squared minus 12x. Distribute the signs, and I get positive 6x minus 12. Then my final number would be plus 6, because x can fit in 6x 6 times. 6x minus 12, and if you subtract them, I get a remainder of 0, which means this would be my correct answer for the first question. Alright, second one, x cubed plus 2x squared. This one here, we have no x value, so we go straight to 32, but that doesn't mean that we write 32 right after the x squared. We need to write 0x plus 32. Divide that by x plus 4. Now x fits in x cubed. We're going to focus on the very first terms once again. X squared, x cubed, and then plus 4x squared. Subtract these guys. I'm going to distribute the signs. Cancel these out, and that's negative 2x squared plus 0x. How many times can x fit in negative 2x squared is negative 2x. So minus 2x squared minus 8x. These distribute the signs. We'll give you positive 8x down here. Bring down the plus 32. And how many times can x fit in 8x? It will be plus 8 times. So 8x plus 32. Subtract it and you get a 0. And this will be my answer. Now if you notice, this one is not factorable. So your answer here would be just this. However, if you get x squared minus 2x plus 8, well, actually, this one is also not factorable, so we'll just leave it as it is. But if this was factorable, I wanted to see x plus 4 times this, if there were two more parentheses like that, which will clearly tell you the 3 zeros of the function. All right, next, we have 4x cubed minus 7x squared minus 11x plus 5. Then we have 4x plus 5, so it's a little bit more complicated than before. 4x within 4x cubed, x squared times. 4x cubed plus 5x squared. Subtract these guys. Make sure you distribute them. That would be minus 12x squared minus 11x, because that's negative 5x squared. Bring down the negative 11x. 4x can fit in negative 12x squared minus 3x times. So minus 12x squared minus 15x. Again, distribute the negative sign here, which will get you positive and positive. And that will be me 4x, bring on the plus 5. And the last one is just plus 1, because 4x plus 5 fits in 4x plus 5 just one time. Or 4x fits in 4x just one time. Last one, 6x cubed minus 16x squared plus 17x minus 6. We will divide this by 3x minus 2. So here, 3x fits in x6x cubed 2x squared times 6x cubed minus 4x squared. Distribute the negative sign here. These two will cancel out, minus 12x squared plus 17x. we're going to write minus 4x up here. So that'll be minus 12x squared plus 8x. And then you would distribute the negative sign. So you get 9x, bring down the minus 6. So this would be plus 3, 9x minus 6. Distribute the negative sign here, you get 0. Everything will cancel out. So these would be my answer. Okay, so like I told you before, we'll be talking more about the long division once we get back, once we start next week. I'm going to go over the test number 2 for the quadratic. Let's see, so quadratic test would be this one. Right. Okay, so consider the quadratic equation below where you're solving by factoring. So first, you need to factor out 3 outside from everything. And then you would just write x plus 8, x minus 1. So at this time, I would like you to take your test out and just verify your answers for me. So solve the equation by completing the square. So 3x squared, oh, by the way, this has to set equal to 0, so we have to have x equals negative 8 and x equals to positive 1. Solve the equation above by completing the square. So 3x squared plus 21x minus 24 is equal to 0. You can divide everything by 3 first because your first step is to always get a value to be 1. So you get x squared plus 7x minus 8 is equal to 0. Then you would move the 8 to the other side. Now, what's going to happen is the b divided by 2 squared is what you would add to both sides of the equation. So b divided by 2 squared here and plus b divided by 2 squared here. Now, what is the b divided by 2 squared value? Is that it's 7 over 2 squared, which is 49 over 4. So what that would mean for us is that I am going to add 49 over 4 to both sides of the equation. Then that would mean this part can be factored in such a way that it's x plus the b divided by 2 squared is equal to, I'm going to convert this into a form of a fraction with a denominator of 4. So 32 plus 49 over 4. So x plus 7 over 2 squared is equal to 81 over 4. Square root both sides of the equation. I get x plus 7 over 2 is equal to plus and minus 9 over 2. X equals negative 7 over 2 plus 9 over 2. And that would mean that I would get 2 solutions from this, which would be 2 over 2, and that would be negative 16 over 2. If you do negative 7 plus 9, negative 7 minus 9, which would be 1 and negative 8. So again, proving the point that I will get the same exact answers if I were to factor. Solve the equation above by using the quadratic formula. So the quadratic formula is negative b plus and minus the square root of b squared minus 4ac all over 2a. So here what we will do is we can use 3x squared plus 21x minus 24 is equal to 0 and plug in our a, b, c values accordingly. But what's really what would make my life a lot easier would be to just divide everything by 3 and get x squared plus 7x minus 8 is equal to 0, and then you can still use these 3 as your a, b, c values, and that will still get you the right answer. So this will be negative 7 plus and minus the square root of 49 minus 4 times 1 times negative 8 all over 2 times 1. Negative 7 plus and minus the square root of 49 plus 32 over 2. So that will be 81 over 2, negative 7 plus and minus 9 over 2, which will get you the exact same thing as what you have gotten before, which is positive 1 and negative 8. Okay, moving right onwards, calculate the discriminant of the question above. What is the nature of the roots based on your value of the discriminant? So the discriminant is b squared minus 4ac. Alright, so now I want to plug that in. Where a value is negative 1, b value is 4, c value is negative 9. So if I plug those in, 16 minus 4 times negative 1 times negative 9, this would give me 16, I believe, minus 36, which is negative 20. So I will have 2 imaginary or 0 real roots. Okay. Alright, so then fill in the table below. I do not have any real roots in this case, which means I do need to have a testing point. Axis of symmetry, we already know it's negative b over 2a, so that would be used to solve for the vertex. So 4 over 2 times negative 1, or negative 4, which would get me positive 2. So x is equal to 2 would be your axis of symmetry. And then now the vertex here would be when you plug in the 2, so negative 2 squared plus 4 times 2 minus 9, negative 4 plus 8 minus 9, this would give me negative 5, so my vertex would be 2 comma negative 5. If you're wondering what I just did here, you're plugging in the 2 into the equation up here so that I can end up getting the y value for that x value. So the x-intercept and the y-intercept is the one that's really easy to figure out. Max and min, it's going to be a is less than 0, so that will be max. And I need to find out what my x-intercept is. Well, the x-intercept cannot be figured out because of the nature of my roots, but I can still use the quadratic formula to say where the two imaginary roots would be. So here would be negative 4 plus and minus the square root of negative 20, because that's what we have found out for our discriminant, over 2 times negative 1. So negative 4 plus and minus, if you would like to distribute, this is another question in itself, simplifying the radical for negative 20 would be 2i square root of 5 over negative 2. Now, if you were to cancel out the 2's from both here and here, that would be 2 plus and minus I square root of 5. So if you're wondering just how I was to exactly get that, square root of 20 is the same, square root of negative 20 is the same thing as saying 3 different things. Square root of 4, square root of negative 1, and then square root of 5. This will become 2, this will become I, this will just come down as square root of 5. Okay, so at this, and then dividing by negative 2, well, because of this plus and minus sign, it really doesn't do anything for the secondary part, but the first part will turn out to be positive. So 2 plus and minus I squared of 5 would be your answer. Now, a testing point, to get that, it's going to be much easier for us to do this after we plot this. So 2 comma negative 5 and 0 comma negative 9. So by using the rule of symmetry for our quadratic, it's 2 units to the left from the axis of symmetry, so if I move 2 units to the right of the axis of symmetry, I get the point right there. So I get a really nice parabola shape, not really shown on the graph, but you can get that little tiny graph on the bottom there. And this testing point right there would be 4 comma negative 9. It's symmetrical from the y-intercept based on your axis of symmetry. All right, check the boxes that will yield out negative 1 as the product. Now, some of you guys have asked me questions about this. I know that the instruction was probably like a little bit unclear, but what that means is you multiply I to the 9th with I, and that becomes I to the 10th. Now, does that equal negative 1? If it does, then you just put a check next to it, which it does. Because I to the 10th, if you divide 10 by 4, you get a remainder of 2. So you're really looking for anything that gives you a remainder of 2 once divided by 4. I to the 37th power, well, obviously that is going to also be an answer because I to the 38 divided by 4, 9, 36 is 2. So 37 times I to the first power, that's going to give you 38. So 99 times I to the first power, well, that's I to the 100th. Unfortunately, that is divisible by 4, so that means that this is going to give you positive 1 instead. I do not want to put a check mark on this one. So if this was I to the 4th power, this would, if I multiply this with 99, that's I to the 101, I to the 102, I to the 103. Now one of these guys will give you a negative 1. Only this guy, I to the 102, will give you a remainder of 2. So I'm going to put a check mark here. Now I to the 234th power times I, which will give me I to the 235th power. If you divide that by 4, you get 5, 20, 35, and then you could fit 8, 32, and 3. This will give you a remainder of 3 once multiplied by together. That means that if you multiply I to the 2nd with this, you get a remainder of 4, next one on the list. And then I to the 3rd with 234 will give you a remainder of 1. So you're pretty much trying all of these together and then just trying to get the answer. So I to the 3rd with I to the 234 would be 237. This would be 236. But if you were to divide that by 4, that's perfectly divisible, as you can see. So that's going to give you I to the fourth power. So next one is I to the first, and this one's I to the second. So you're going to put a check mark on the very bottom one there. So if I were to clear up all of these answers, the answer should look like this. Because the rest of them, these won't give you the -1. Only these guys will get you the remainder of 2 when divided by 4. Now, for the next couple of questions, they're very, very simple to do because they are simply just simplifying complex numbers here. So 7 minus 7i plus 2 minus 7i. We're going to combine the real numbers together, which will give you 9 minus 14i. So that would be the answer there. This is -7 minus I times -7 minus I, which means 49, and then this would be plus 7i, and then plus I squared. So 14i, and this would become simply -1, so plus 48 is going to be the answer. -9 minus 6i over -1 plus 3i, well, you will have to multiply by what we call the conjugate from top and bottom, as we have discussed before. So when you multiply these two together, you get 9 plus 27i, and then plus 6i plus 18i, all over. This would be 1 minus 9i squared, if you were to FOIL it out and just cancel the two parts in the middle. So at the end, what you're going to get is you're going to get 45i. Oh, I'm sorry, that's not it. You're going to get 33i, and this is 18i squared. So that will turn out to be minus 18, so -9 all over. This would be -1 for the I squared. -9 times -1 is plus 9, so this would be just 10. So what I would do is I would leave it as -9 plus 33i all over 10. And I cannot simplify this any bit further than that. All right, next questions. Simplify the following radicals. This and this and this. This here would be, oh, not 3, because I can divide this in 2. Square root of 36, square root of -1, square root of 2. This one, let's see, what would we have? Square root of 36 once again, square root of -1, square root of 5. This one here, I believe, let's see, if we do 2 square root of 256, square root of -1, square root of 2, I believe that's going to do the deed. So then if I were to simplify these, it would be 6i square root of 2, 6i square root of 5, and then 16i square root of 2. These three would be the answers to these three questions. Okay. All right, moving on to number 4. Take a look at the graph below. What are the x-intercepts of the function? Write down the function in a factored format. Well, it looks like we have two clear x-intercepts there. So the x-intercept is at -5, 0 and at 0, 0. So write down the function in a factored form. So y is equal to a times x plus 5 times just x, or x minus 0 if you would prefer to use that instead. But it doesn't matter either way. And the next thing is, using a testing point of your choice, find the a value. Well, the testing point that, you could utilize pretty much anything here, but I believe the 1, 2 seems to be the one that's really obvious, and it gives you the smaller numbers. The smaller number is easier math to deal with, right? Okay, so next thing what we're going to do here is we're going to take a look at how we can utilize that testing point, which is 1, 2, and plug it in so that we can find out what a value is going to be. So y is equal to a times x plus 5 times x. We're going to be utilizing that from our answers to the first part. And then you're just going to simply plug in 1 for my x and 2 for my y. So 2 is equal to a times 1 plus 5 times 1. So 2 is equal to a times 5 times, 6 times 1, which would be 2 is equal to 6a. A would be just 1 over 3. So my final answer would be y is equal to 1 over 3 times x plus 5 times x. If you were to write that in a standard form, it doesn't matter which way you write this, but y is equal to 1/3 x squared plus 5 over 3x. That's also acceptable once you multiply everything through. Okay. All right. So now let's move on to the next question, which is how are the x-intercepts in the axis of symmetry? I believe you said somewhere along the lines of average of x-intercept is equal to the axis of symmetry. This is something I mentioned this to you over and over again before. There are multiple ways in which you can find out the axis of symmetry. It's not just always negative b over 2a once you're given in a standard format. All right, so now I want to find the vertex h comma k. So the vertex h comma k here would be to just find the average of the two x-intercepts, which will happen at negative 2.5. So at negative h equals negative 2.5, you just have to simply plug that into the calculator, so into the function here. So to find out the k value, I would say y is equal to 1/3 negative 2.5 plus 5 times negative 2.5. So this would be the equation that you would use to solve for it. So I get 1/3 times 2.5 times negative 2.5. So that would be, I think, 1/3 of, I believe it was 6.25 negative. So your answer here was somewhere along the lines of negative 6.25 over 3. If you were to type that into your calculator, I believe the answer is somewhere along the lines of negative 2.08. Okay, so the next question, now the number 5, is the table shows the heights. Oh, actually, before we move on, I just wanted to verify real quick. So if you go down here, the vertex which is located, I believe that's all somewhere around negative 2. So I believe our answer here around negative 2.08 should be around the rough ballpark there. Okay, so the table shows the heights y of a basketball shot given the time x. So now we have the function, time versus height. Write a function that models the height of a basketball shot over time using a quadratic regression on your graphing calculator. So what we're going to do is we are going to take a look at the quadratic regression model based on this data here. So I'm going to go to my calculator, and I'm simply going to type those values into the edit and into the list. All right, so I'm going to type in 3, 4.5, 6, 7.5, 9, and 10.5. And then I'm going to move on to my second list, which is 5.45, 8.153, 9.22, 9.97, 10.16, 9.53. And after that, we go stat, calc, regression, number 5, those two lists, and we can use variables just to store the y values in there and calculate. So there we go. We will have the quadratic regression as negative 0.16, so you can write that down somewhere, and the b value as 2.678, and c value is negative 0.99. And so if I wanted to write down the equation for this, so if I wanted to write down the equation for this, I would write y is equal to negative 0.16x squared plus 2.678x minus 0.99. What is the maximum height that the value would reach? Well, you could use your graphing calculator to do that for us. And then how long is the basketball in the air? So here's what we're going to do. We're going to be using our graphing calculator to our advantage. You have y is equal to as stored for me, and you're going to press graph. And unfortunately, the vertex is kind of a little bit to the right, so I'm going to change my window setting to make it y max to be 15, and let's make x max to also be 15ish. And so you get a little bit better curve to get. Now the x-intercept is clearly not shown, so maybe I need to expand my x max just a little bit more, maybe about 20. So there we go. I have two x-intercepts and the vertex clearly shown on here. So now what I'm going to do is I'm going to press second trace, find out maximum, left, and then right. So I get my vertex to be at 10.21, where the time would be 8.36. So if I go back to my question here, what is the maximum height? I will say negative, not negative, 10.21, whatever the unit that was given to me, but it's not. So I'm just going to write that as my maximum height. How long is the basketball in the air? Well, that is when you shot up the basketball in the first place. Let's see over here. So that is when you first shot up the basketball. Now, realistically speaking, that would mean that your y-intercept, it should not be negative because you're starting from the ground level, which is at 0. So you're really looking for the two x-intercepts that's given to us. So if you just press second trace here, and if you go to 0, the left bound, the right bound, the two zeros, or you could just use the graphing, the quadratic formula to really just solve for this. Doesn't really matter which way. The one of the zeros here would be at negative 0.37. I'm sorry, positive 0.37. And then you're going to press second trace, press 0. And then for the right bound, we're going to find another 0, which is at 16.35. So what that means for us, okay, so how we figure this out as a part of our answer, is that if this is your parabolic shape, the one of the x value happens at 0.37, and the other value happens at 16.33. This is the duration from the first x-intercept to the second x-intercept. That's how long the basketball is in the air. Because as soon as you started shooting up the basketball from when the ground was at 0, and then it comes down back to the ground level, that's when it's up in the air. So you will have to subtract these guys. 16.33 minus 0.37. So around roughly 16 seconds is what you're looking for. So obviously this one will give me 15.96 seconds. That's also acceptable answer. So anywhere around that would be fine. And if the basketball is located at 11, 8.23, does the basketball go through the hoop? Once again, if you use your calculator, what do we have to do? Second trace, and then you want to press value. And then the value at this location, which says at 11, 8.23. So you just want to type in 11 as x, and look at that. Not y value is actually 9.10. So we do not want to say that because we were looking for 8.23. So we want to say no. At 11, at x equals 11, y is equal to 9.1, not 8.23. Somewhere along those lines would suffice. Okay, so two more questions to go. General equation will be ax squared plus bx plus c. Vertex form will be a times x minus h squared plus k. Factor form will be a times x minus p times x minus q. Key features of the graph: y-intercept, vertex, and the x-intercept. I hope you guys remember that this was actually part of your notes, and you can just literally copy and paste this. It's not something where I can take a look at whether you guys have the notes in front of you or not, but it should be somewhere in your notes, and this is the table for it. Model rocket is launched from the roof of a building. Its flight path is modeled by this equation. What is easily identified from the equation? Well, obviously, the y-intercept, but in the context that was given, okay, so it's launched from the roof of a building. So what does that tell us? The y-intercept is when the time is 0 and the rocket ship, if I were to just draw like a picture, if this is a rocket ship and this is the height of the house or height of the building, it's actually when it starts its flight path. So this plus 10 tells you how high the building is. And then for part B, it says rewrite above equation in vertex form. So if I wanted to write in the vertex form, I could use negative b over 2a to find out my h value, which is negative 30 over 2 times negative 5. which is negative 30 times over negative 10, which is positive 3. Now plug that in back in here, 3 squared plus 30 times 3 plus 10. Why do we want to plug it back into the original equation? To find out the y-coordinate, of course. So 9 plus 90 plus 10, negative 45 plus 90 plus 10. So that will give me 55 for my y value. So my vertex is 3, 55. So then here we get y is equal to negative 5 times x minus 3 squared plus 55. Okay, so now how did I get this as my vertex form? A value, negative 5, coming from here. H value coming from the axis of symmetry, and 55 coming from once I plug the value back in. Okay? All right, when does the rocket hit the ground? Well, that is when it goes to this path and it's really looking for when y value to be 0, right? So you can just set the first, this equation to be 0 or this equation to be 0. It doesn't really matter which one you use. I'm just going to use the first equation because I believe most of you guys did it that way. So negative 5t squared, the equation is plus 30t plus 10 is equal to 0. Then you can divide everything by 5, which will get me, or divide by negative 5 actually. That will give me minus 6t minus 2 is equal to 0. And then you can use the quadratic formula. So that will give me negative 6, which is positive 6, plus and minus the square root of 36 minus 4 times 1 times negative 2 all over 2 times a, which is not positive 1. So 6 plus and minus the square root of 36 plus 8 all over 2, which is 6 plus and minus square root of 44 all over 2. 6 plus and minus 2 square root of 11 over 2. Well, you can just stay at this stage, but what's really important is that from here, I don't have to rewrite this down, but what's important is that you need to find out what the correct answer is going to be. Now, because we're talking about t as time, we cannot do 6 minus square root of 44 over 2, because if you type that into your calculator, this will get you a negative number. So that's no good. So we only want to look for the one that's positive, 6 plus square root of 44 divided by 2. And if you were to just type that into your calculator, let's see what we get. Let's see, and then that, I believe that final answer will be 6.31 seconds in time. Okay, so the last question is, what is the value of c in order for it to have no solution? So then that would be b squared minus 4ac would be less than 0. So that's 81 minus 4 times 2 times c, which is less than 0. So 81 minus 8c is less than 0. So 81 less than 8c divided by 8. So 81 divided by 8 is, c is actually greater than that value. Remember, if it's no real solution, that means the discriminant has to be less than 0. So that means that I'm going to set this as less than 0, plug in your b, plug in your a, plug in your c value, and then you're going to get that. And then you're going to just simply move this to the other side, get ac positive and 81, don't switch the sign, and divide both sides by 8. If the c value was 0, which means I'll end up getting this, how many solutions would you get? Well, you can still use b squared minus 4ac, and if you were to use that, a value would be 2, b value would be negative 1, but the c value is 0. So plugging it once again, 81 minus 4 times 2 times 0, well, that will simply just turn out to be 81 because this will be 0. So I will get 2 real solutions. If the question was changed so that b value is positive, how will the discriminant be affected? It will not be affected. As we discussed in the review sheet, even if it's positive or even if it's negative, remember, it's b squared minus 4ac. No matter what you do, it will always turn out to be positive. So regardless of what the sign of b is, that doesn't matter. It's the value of b. That's what's important, not the sign of b. How many real roots does the following graph have? This is the last question. You have 1 real, clearly shown here, and you have 2 imaginary, or 0 roots here. All right, so I think that's it for the test. Whew, that was a that was a lot. But remember, this was a comprehensive quadratic test, and I believe, anything that you see from this point onwards from quadratic, I believe you guys have it. The reason why I wanted to spend so much time on it was because there were so many topics regarded with quadratics, and I'm so proud of it. Every single one of you guys being able to complete this. You remember, this was not supposed to be able to be finished within like a 40-minute time period. It was kind of meant to be more so than, if you finish all the 7 questions, that's superb, excellent job for you. But 5 questions is what's good enough for me. So I hope that after you see this, you feel a little bit better about how your answers went. That's it for today. You're just checking your answers for the test and the homework, and I just really didn't want to give you any work for over the weekend. So thanks everybody, and I'll have a great weekend, and I'll see you guys next week.